Right, so for today, we'll be having algebraic curves. So how to trace algebraic curves? What are the parts necessary for us to be able to trace properly and analyze an algebraic curve? So for us, let us take first the forms of algebraic curves. First is the implicit. When we say implicit, it means that the x's and the y's are combined and then they are not isolated. So just look at the first example where you have x squared plus y squared minus 4x plus 10 plus 0. So all of the terms or all of the variables are on one side and then equals 0. Or sometimes it can be this form wherein still the variables x and y are together and then you can see a constant on the other side. And look at number 3. You have the variables on the left and also some variables on the right wherein nothing is isolated. This is called the implicit form. So we still have to fix this form in order for us to be able to evaluate properly the curve. Next, the explicit forms. So the explicit forms, it's easy to look at because y is already isolated, just like the first 3 examples that we have here. All right. So let's go to the types of algebraic curves, the common types that we will be dealing with. Among a lot of types, we will only be dealing with 4 types here. The first is the polynomial function. Let's just call this type 1. The next is the rational function. The third is similar to number 1. However, look at the left side. The left side is squared. So that means we will have to do something about it. And then the last one, the fourth type, is similar to type 2. However, the left side or the y is also squared. So we will apply similar conditions as type 3. So px and x and d of x here are all polynomial functions. So for the first one, some examples are this. Y equals 4x cubed minus 2x. This is a polynomial function. Number 2, it's the same. It's a polynomial function. However, it is factored in form. Next, this is the rational or the fractional function. So there are 2 polynomial functions. One is on top, the other one is in the denominator. And it can be unfactored or factored form. It's up to us to find out which is easier for us to deal with. With me, typically it's the factored form. Next type, the type 3. Similar to the ones on top, however, look at the left side, you have a square. Next is the type 4, similar to the second type, however, the left side is square. So how do we analyze those? So in order to discuss and completely analyze and trace the curves, sometimes if it's given in the expanded form, what we do is we try to factor it out. And then some of the important parts are symmetry along the x-axis, along the y-axis, and along the origin. Types 1 and 2 are not symmetric with respect to the x-axis, whereas types 3 and 4 are symmetric. And then I'll show this to you in a while. And then the fourth is are the intercepts. There are 2 types of intercepts, as you have, as you may have recalled from your general mathematics. We have the x-intercepts, where we let y equals 0, and the y-intercepts, where we let x 0. The asymptotes, so only those type 2 and type 4, so meaning only those with denominators or with fractions will have vertical and horizontal asymptotes. In our case, okay, so take note of these. To solve for the vertical asymptote, let y approach plus or minus infinity. That is, equate the denominator to 0 and solve for x. So basically, it's just denominator equating to 0. Note number 2. To solve for the horizontal asymptotes, divide the numerator and denominator of the equation in the expanded form by the x term of the highest degree. And then let x be approaching plus and minus infinity. And then solve for y. After that, we look for the extent or basically the behavior of the curve as it approaches negative and positive infinity. This is how I recall this. I just, use this bar. And this is quite useful when you're going to calculus. So what does D stand for? It stands for domain. So domain is basically the set of all permissible x values. I stands for intercepts, so those are the x and y intercepts. S stands for symmetry, so symmetry along the x-axis, along the y-axis, and along the origin. B stands for behavior, so those are the extents that has been stated earlier. A stands for the asymptotes, and R for region. So let's go to this. So when I say here domain, this is basically set of permissible x values. So typically, this one, I just look at this after I draw the curve. So the intercepts, as I said earlier, there are two types. There's what you call the x-intercept and the y-intercept. For the x-intercept, I set the y to 0 and then I solve for the x value. For the y-intercept, set the x to 0 and then solve for the y. Symmetry, there are three types. So in here, along the x-axis, along the y-axis, and along the origin. So how do we solve for this? What I do is I change y to negative y and then check if the equation or the function changes in form. If it changes, that means there's no symmetry. And then this one, change x to negative x and then check the form. And then this one, change x to negative x and y to negative y and then check the form. Next is the behavior. So the behavior, there are two types. As x approaches positive infinity and as x approaches negative infinity. Next, the asymptotes. Actually, we have three types of asymptotes: the horizontal, the vertical, and the slant asymptotes. However, for our case, we will only be focusing on the two. The vertical asymptote, or what we call the VA, what we do is we set the denominator equal to 0 and then solve for the x values. And then the other one is the horizontal asymptote, or the HA. So how do we solve this? So I would like you to take note of these. Note that if, for example, you have y is equal to numerator and denominator of x, if the degree of the numerator is less than the denominator, the horizontal asymptote is equal to 0. If the degree of the numerator is equal to the denominator, the horizontal asymptote is a over b. So what do I mean by a over b? So whatever the highest degree of the numerator is, look at the coefficient of that. And then whatever the highest degree, so basically their coefficients are a and b. And then lastly, if the numerator is greater than the denominator, there's no horizontal asymptote. There is a slant asymptote, but then there's no horizontal. Now, we have defined an asymptote as a line that we continuously approach but we never touch, right? That is true for the vertical asymptote. However, at times, we have to check for crossing at HA. So how do we do that? What we do here is HA is equal to the original function. Whatever the given function is, you equate that and then solve for if applicable. All right? Lastly, we have what you call the regions. The regions come from the x-intercepts and the vertical asymptotes. Okay, let's go to some examples. So in here, it says, discuss and trace the curve. So again, we have domain. As I said, let's answer that later on. Intercepts. It might be wise if we factor this because that at the moment is unfactored in form. So let's do synthetic division. If I try dividing it by x equals -1, I'm left with 1. This is -1. That's -6. +6. So that means it was reduced. So it's true that x equals 1 is a factor. And then you're left with x squared plus x minus 6. So if I would want to combine it to have a factored form, I would say y is equal to x plus 1, and then I'm left with an x squared plus x minus 6. You can still factor this as x plus 1, x minus 2, and x plus 3. So if I ask you, what is the x-intercept? What we do here is, we set y to 0 and then solve for the possible values of x. If I ask you, what is the y-intercept? You solve for the y values when x is 0. So let's solve. When y is equal to 0, the x values are negative 1, 2, and negative 3. So we will use that later on. What else? When x is equal to 0, let's just look at the original problem. When x is equal to 0, y is just negative 6. All right, so we have an answer. Let's go to symmetry. For symmetry, as I said, along the x-axis, what we do is we change y to negative y. I have a question. Is this one the same as the original question? It's not. So along the y-axis, what we do here is we change the x to negative x. And then let's simplify. That becomes negative x cubed plus 2x squared plus 5x minus 6. So let's compare. Is this new form the same as the original form? They're not. And then what we do is we change, for the origin, we change both x and y. So let's just copy the one on top, right? So is this new one the same as the old one? It's not, right? So that means there's no symmetry. I can see here that symmetry, there's none. And what type is this? This is actually, so for the behavior, as x approaches positive infinity and as x approaches negative infinity. So what I would do is I would just go back to this later on. Lastly, second to the last is asymptotes. Since it does not have a denominator, I can say no vertical asymptote and no horizontal asymptote. All right, so I have my parts. Last part is what you call the regions. As I said earlier, the regions come from the x-intercepts and the vertical asymptotes. So the x-intercepts are negative 1, 2, and negative 3. That's why I placed a star. And then I don't have a vertical asymptote. So these are the only 3 x values. So take note that number of regions is equal to x values plus 1. So since we have 3 values of x, we should have 4 regions. So if you have a number line, let's just say, let's start with negative infinite, negative 3, negative 1. So these are the regions. There are 3 numbers, there would be 4 different regions. What I would put in here is actually the factored form of the question. So x plus 3, x plus 1, and x minus 2. So I'll just place here on top x plus 3, x plus 1, and x minus 2. At the bottom, I'll place y. Now, this is what you call the table of signs. What I usually do is this. I would look at the number in here at the bottom and look at the line. So negative 3, if I plug in negative 3 in any of the 3, it will make x plus 3 0. What does negative 1 make 0?
X plus 1.
X plus 1. So I would put 0 on the line. For number 2, I would put 0 in here. So what I would do is I would try to look for a test value. For the test value, it says here, let's think of a number less than negative 3. So let's just say negative 4. Okay. What I would do is this. If my test value is negative 4 for the first column, negative 4 plus 3 is negative. Kasi it's a table of signs. You don't actually need to place numbers or values. Just place the signs. Alright? Now, -4 plus 1 is also negative. -4 minus 2 is still negative. Now look at this. This is a negative sign. And then what is this? This is 0, right? So after negative, if it becomes 0, it becomes positive now. So is this correct? Let's try. Let's think of a number between -3 and -1. Let's say -2. -2 plus 3, isn't that positive already? So that means all the other numbers would be positive. So it is crucial that you know where it becomes 0. So in here, look, even if I don't have a trial value, I know that it's negative. The 0 is there, so that means it's still negative until I reach 0 or until I cross 0. In here, what would be the signs, guys?
Negative.
Negative, negative, positive, right? So you are multiplying three terms. So when you multiply three negatives, what is the sign?
Negative.
Negative. When you multiply this, it's positive, negative, and positive. So I have a point why I'm making this. If I were to graph this, okay, so in the graph, what we do here is, let's go back to the analysis. Let's look at the ones with stars. Okay, I need to plot this because this is an x-intercept. -1, -3, +2. All right, what else? Oh, there's -6. 1, 2, 3, 4, 5, 6. Okay, so those are the intercepts. After that, I know that there's no symmetry. There's no asymptotes. Okay, I don't have anything to deal with here at the moment. Let's look at this. So what are the regions? The regions are from -infinite up to -3. So what I would do here is I would draw a very light line just to create the regions. So the regions are from -3 to -infinity, -3 and -1, -1 and +2, 2 up to +infinity. And then look at this. What is the sign in here? From -3 to the left, the sign is negative, right? So that means if the sign is negative, I should not have any graph on top. I will cross this out. So I know I don't need to draw in here. Look at this, between -3 and -1, the graph is positive. So the graph should be found on top. That means if it's found on top, there should not be anything at the bottom of the x-axis because anything at the bottom of the x-axis is negative, right? Between -1 and +2, it's negative. So I should not have any graph on top. Lastly, from 2 onwards, it's positive. So I should not have a graph in here. So I would approximate, because this is an approximate, you're not going to ask to draw an exact graph of this. So look at this. This is -1, this is -2. So let's just say, let's just draw that. So from here, we go down, and then there. And then we know that it will pass through here. But then is this one the middle of the 2 points? No, right? So what I usually do is this. This is -1, this is +2. So the middle is somewhere here. So let's just say here, I'll draw the line. And then I'll draw another line here. Something like this. And then can you please help me count, guys? How many changes in slope do I have? Diba 1 going up, 2 going down, 3 going up. So there are 3 changes in slopes or 3 changes in sign. And look at this. Isn't it that the original problem is third degree? So that means if it's third degree, 1, 2, 3. That's correct. So let's look at the approximate graph. It's this. First region, second region, third, and fourth. But then with them, it's the final graph, so it does not have the shading. With me, I shaded, but then look how many regions do I have? 1 region, 2, 3, and 4. Just like this, there are 4 regions. And then our graph is similar to the one we have here. So that is the graph of a polynomial curve. We're not yet finished because earlier I said the domain. Can I safely say that the domain, it extends to the left and right? Because for polynomial curves, the domain is all the real numbers, all the time. Now, let's look at this, the behavior. as the x goes to the right, am I correct in saying that the y goes up? So that means the y goes to positive infinity as well. As x approaches to the left, y goes down. So I can say that the y approaches negative infinity. So this is the complete analysis of your curve with the trace. So let's go to case number 2 or type number 2. Actually, this one is not type 2 because for type 2 it's fraction. This one is sort of like type 3, but then it's not given as y squared. So what we do is, let's write domain. Let's solve for domain later. Intercepts, we can't solve it yet because it's ugly form. Symmetry, behavior. Okay. So I can say here that y is equal to the, let's try synthetic division again. 1, -5, 2, and 8. Let's divide that by -1 again. 1, -1, it's -6, 6, it's 8, -8. So that means it's x plus 1 and x squared minus 6x plus 8. But then it's not yet complete. I can still simplify this as x plus 1. This is x minus 4 and x minus. So now I have simplified it. So maybe I can already solve for the x-intercept and the y-intercept. For the x-intercept, the y should be 0. For the y-intercept, x has to be 0. So when y is 0, I have values of my x as -1, 4, and 2. So let's just put a star so we know we will go back to this. For the y-intercept, guys, when x is 0, let's look at the original question. 0, 0, 0. I'm left with y equals the root of 8. I know that the root of 8 is something greater than 2, but something less than 3. So I'll take note of that later on. Let's go back to this. All right. Symmetry, this one, no symmetry. But if it's type 3, it would have symmetry. Behavior, as x approaches infinity, we don't know yet. As x approaches negative infinity, we don't know yet. So let's get back to this later on. Asymptotes. So for asymptotes, there are two types again, vertical and horizontal, but then this is polynomial, so there is no HA, there's no vertical asymptote. It's sort of polynomial, but then inside a radical. Now, lastly, let's go to the regions. Let's go to the next page for regions. The regions come from the x-intercept and the vertical asymptote. So since we have 3 values for the x-intercept, I can say -1, 4, and 2. So how many total number of regions? So if I start with negative infinity, the next is -1 because let's arrange that in order. Next should be +2, next should be +4, next would be infinity. Okay. And then what I would do here is place the factored form. I have a point where I'm making this. All right. Let's place the zeros. What will zero out at x equals -1? X plus 1. What about at x equals 2? What will zero out?
-2.
So the one at the bottom. And then at 4, it's x minus 4. All right. So let's think of a test value. My test value, of course, typically I would test values on the leftmost. So what would be my test value? Test value is x equals negative, let's just say -10. It's okay to test -10. If it's negative, what would be my signs? -10 plus 1 is negative, -10 minus 4 is negative, -10 minus 2 is negative. Now, I have passed through 0. So what would be the sign in here, guys?
Positive.
Right. Positive, positive, and positive. What about this one?
Negative, negative, positive.
negative, negative, and then positive, because there, once you cross 0, that's when you become positive. So this one, last one.
Negative, positive, positive.
Very good. Now you're multiplying three negative terms. That's negative. That's positive. This is negative. This is positive. But take note, guys. This one is just the product. In here, I placed y. Let's look at the y. Y is inside the square root. Do you have a square root of a negative number? Can you have that? Isn't it that the square root of a negative number is imaginary? So that means if I apply square root to this, I can't have any graph in here because it's imaginary, and you only draw real numbers. The square root of a positive number is still positive. Some of you might say, why is it not plus and minus? Look at the question. The question does not contain plus and minus. It says y is equal to the positive square root of that. So we're only taking the positive sign. Again, the square root of a negative number is not acceptable. And then square root of a positive number is still positive. So look at this carefully. So if I were to draw this, let's go to the intercepts. Let's go back. Intercepts are negative 1, 4, and 2. 1, positive 4, positive 2. So it's this. And then y-intercept is square root of 8. So that means it's somewhere in here, right? There's no symmetry. And then we will go back to the others. Okay. So that means let's draw the regions. What I would do is I draw very light lines in here. Okay. And then I try to look at the table of signs. The table of signs says that beyond negative 1, there should be no graph. Either on top or bottom, I could not have any graph. So shade that. Between negative 1 and positive 2, the sign is positive. So that means let's shade the negative side. I cannot have any graph in here. From 2 up to 4, I should not have any graph in that region. Lastly, from 4 onwards, it's positive. I cannot have any graphs at the bottom. So look, how would you draw this? What I would do is I'd connect this. So that one and possibly that one. Because this one, there's a radical. What's inside the radical? The x value. So that means the graph closes in towards the x. So this is how I would graph this. So let's see how it is being graphed. This one, when you notice, sir, why does it have up and down? The question that they were originally considering probably would be this one. So probably for this curve, what they have considered is y squared is equal to x cubed minus 5x squared plus 2x plus 8. Because when you are the one applying the square root, you will have a top and bottom counterpart. Because the square root of this one, you don't know yet, but you have to recall, guys. If, for example, if I say if y is equal to the square root of 4, you can say y is equal to 2. But if y squared is equal to 4, y is plus and minus 2. Do you notice the difference between the two? In here on top, it's specifically stated that y is the positive square root of 4. Whereas in here, you know that y squared is 4. You are the ones who will be applying the square root. And you don't know whether it's a positive or negative answer. So in here, you have to show both possible answers. Whereas on top, it's only stating y is the positive square root of 4. That's why in here, since it's just the positive square root, we only take the upper half of the figure. But if it's, for example, this one, this is type number 3, you can say there is symmetry along the x-axis because whatever you find on top is symmetric to the ones you find at the bottom. So let's go back to this. That means the behavior as x approaches negative infinity, no graph for x approaching negative infinity. Sorry, I was saying one thing, I was looking at the other. But then as x approaches positive infinity, okay, y approaches positive infinity as well. It's as x approaches to the right, y approaches upwards. And then you're asked, how does the graph look like? It's only possible to have a graph from 1 up to 2 and from 4 to infinity. So I can say from negative 1 up to 2, I have a graph. Union from 4 to positive infinity. Now let's go to the last. So for the last problem, we have a problem here. Why? Because it is implicit in form. So what I would do is this. I would first try to combine all those with y on one side. So x squared y plus 6xy. And then all those without y's, I'll just move to the other side. X squared minus x minus 20. And then if I factor out y in here, I'm left with x squared minus x minus 20 all over x squared plus 6x. Now, this one, I can factor this out as x minus 5, x plus 4, and then the bottom, I can factor it out as x plus 6. So, this is already type number 2 because this is rational in form. Okay, let's identify the points. Domain, intercepts, symmetry, behavior, and then asymptotes, and then regions on the next page. For the domain, I know that for my domain, the denominator cannot be equal to 0. When will the denominator be 0, guys? When x is 0 or negative 6. Am I correct? So that means x cannot be those two values. Otherwise, you will be dividing by 0. And then dividing by 0, it becomes undefined. Alright, so intercepts. There are two types. The x-intercept when y equals 0 and the y-intercept when x equals 0. So the x-intercept first. When y equals 0, oh, I have 2, 5, and negative 4. For the y-intercept, it says there that y-intercept can only be obtained when x equals 0, but then x cannot be 0 as I said here. So that means no y-intercept. So do take note of these. No y-intercept, it's important to know this. Now, symmetry. It's not fully squared, so when you try, there's actually none, no matter how you try. Behavior, let's try this later on. X approaches positive and x approaches negative. Let's go back to this. So as I said earlier, an asymptote, there are two types, vertical and horizontal. For vertical asymptote, let's just equate the denominators to 0. So vertical asymptotes are 0 and negative 6. That's why those are restricted in the domain. For horizontal asymptote, what I would do is the degree of the numerator is equal to denominator. So the degree. So y, or the HA, is actually y equals a over b. It so happened that the a is equal to 1 because the degree, the coefficient of x squared is 1. The coefficient of x squared at the bottom is also 1. Therefore, HA is equal to 1. Now, as I said before, look at this. If there is a horizontal asymptote, we have to check for possible crossings at the horizontal asymptote. And how do we do that? We equate the horizontal asymptote to the given function and then solve for x. So, what I would do is this. I'll just check for crossing at the horizontal asymptote. So since the horizontal asymptote, guys, is equal to 1, I'll equate to 1 to the given function. which is x squared minus x minus 20 all over x squared plus 6x. So when you equate them, x squared plus 6x is actually equal to x squared minus x minus 20. You cancel the x squared, you're left with 7x is negative 20. X is negative 20 over 7. Okay, so that means we have a crossing. This is important that we know that. Okay, so all the parts are almost complete except for this. Let's go back to this later on. Now let's solve for the regions. Again, the regions come from the x-intercept and the vertical asymptotes. So x is equal to 5 and negative 4. And ang vertical asymptotes natin are 0 and negative 6. So when we draw this, it should start from negative infinity. Next should be negative 6, negative 4, 0, 5, and last 6 infinity. And then I would write the given equation, so I would know what to do. X minus 5, this is x plus 4, at the bottom is x, and then x plus 6. So I would write all the factors. X minus 5, x plus 4, x, and then x plus 6. In here, at the bottom here, I'd write y. So it's just a combination of all the possible signs. And then I'd write my zeros. So let's try this. Negative 6, it becomes 0 here. Negative 4, 0 is there. 0, zeros at x, and then 5 zeros at x minus 5. So no problem with that, I hope. And then let's try and add test value. Test value should be less than 6. So let's just say negative 10. It can be any number that's less than 6. And then from infinity, negative infinity, less than 6. So let's fill this out. If it's negative 10, this is negative, 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 negative. Now let's fill out the whole table. So this is still negative until it crosses 0. Negative until it crosses 0, it becomes positive. So negative until it crosses 0. Negative, and then crossing 0, it becomes all positive. So negative being multiplied 4 times is positive. Positive, positive, negative, positive. I hope there's no questions in here. And then lastly, 4. All right, let's draw the intercepts. It says our intercepts are 5 and negative 4. So 1, 2, 3, 4, 5. Negative 4, 1, 2, 3. All right, those are intercepts. There's no y-intercept. And then it says there that the vertical asymptote is at 0 and negative 6. So for vertical asymptotes, I would use red. So at 0, so this one, use a dashed line. So x equals 0 is a vertical asymptote. What else? Negative 6. So negative 1, 2, 3, 4, 5, 6. So at negative 6, this is also a vertical asymptote. What else? Do we have any other asymptotes? Yes, we have a horizontal asymptote, y equals 1. Y equals 1 is actually a horizontal asymptote. All right, so I have labeled those parts. I'll draw the regions. The regions are from negative infinity to negative 6. It's already in here. Negative 4 to negative 6, I'll draw a light line. Negative 4 to 0 is here. 0 up to positive 5, so I'll draw a light line there. And then 5 going to infinity. Okay, so let's look at the signs in here. It says there that from negative 6 going to negative infinity, the graph should be found on top. So I should not have any graph at the bottom. Now, from negative 6 up to negative 4, the graph is found at the bottom. I should not have any graph on top of the x-axis. So I don't care about that asymptote. So long as it's on top of the x-axis, I'll shade that. Next, from -4 to 0, the graph should be positive. I'll shade the negative side because I cannot have any graph in here. Now, from 0 to 5, it's negative. So I'll shade everything that is on top. And lastly, it's positive, so I'll shade the bottom. All right, so let's draw the curve. As I said before, basically, asymptotes are lines that you continuously approach but you never touch. You can draw a line that approaches an asymptote and then a line that approaches another asymptote. And then in here, there's an intercept. But then there's an intercept and then there's an asymptote. So you want to approach the asymptote. Now we have a problem because in here we said here that the graph should be on top, but there's an asymptote. Are there any crossing on the asymptote? It says there x is -20 over 7. -20/7 is a bit less than 3. So 1, 2, 3. So let's just say this is your -20/7, roughly close to 3, right? So in here, we know that the graph can cross and then there's asymptote on top. So that means I cross here, but then there are asymptotes in here. So it would want to go near the asymptotes. There is an intercept here on the right, but then the graph is found underneath. There's an asymptote. So it would want to go near the asymptote. And then lastly, look at this. There's an asymptote. However, it did not say anything about crossing because the crossing was only found on this point in the middle, not at the extremes. So I can say there. So if I ask you, as x approaches infinity, as x approaches positive infinity, where does y approach? Am I correct in saying that y approaches 1, approaches this line, and then when x approaches negative infinity, it also approaches y equals 1 because it approaches the asymptote, right? So let's see, is this the curve? There are 5 regions, as you can see, and we also have 5 regions, 1, 2, 3, 4, and 5. So this is the complete analysis of your curve.